Hi, this is Professor Cassidy, and I'm going to go over just a math review for 270. You've got the quiz at the beginning of the semester. Want to make sure that you understand how to do all of the math that's involved with that. I do want to just preface this video by saying that if you are someone who is anxious about math or thinks that you're bad at math, there's a good chance that you had a bad math teacher at some point in your life, or a math teacher that wasn't compatible with your learning and just made you feel like you were not good at math. So this is just a really common theme that I've seen with students. The thing is that there's just so many different ways to do math problems, and any problem, the way that you do it that brings you to the right solution is an okay way to do it. But I know it's not traditionally taught that way in school. So I want you to just give yourself some grace and trust that once things are explained to you in a way that you understand, you'll be able to do this math without problem. I also want to say that I can only explain math to you the way that I understand it. So if after this video you still have questions, you're not understanding some of it, please reach out to another professor. Definitely you can reach out to me. I will connect you with somebody else to give you a hand so that you understand it. You are going to have to know everything that's on here in order to succeed in this semester. All right, let's get into it. This is just a list of the topics that we'll be covering, and I will be sharing these slides as well, so you'll be able to find things and go ahead and skip forward to any area you need to review. All right, first, micrograms to milligrams. So this is 1 microgram. You can see it's just a tiny dot here. And then this big cube over here is 1,000 of those micrograms, and it's 1 milligram. So when you're looking at that, you could say that this small one here on the left is 1 microgram, or 1/1000th of a milligram, and the one on the right is 1 milligram, or 1,000 micrograms. So looking at something in the middle, this is 125 micrograms. You can see it's 125 of these little things, or 125th thousandths of a milligram. Just wanted to give you a visual representation of these different numbers so you understand when you're trying to convert them. The same is true of milligrams to grams. 1 milligram is I'm sorry, 1 gram is 1,000 milligrams, so a gram is bigger. Okay, so how do you convert it? So from going from 125 micrograms to 0.0125 milligrams, you can do it two ways. The first, and this is the way I do it, is you just move the decimal point 3 places. If you're going from microgram to milligrams, you just move it 3 places to the left. So you would come from 125 to 0.125. Or if you are going from milligrams to micrograms, you would move it 3 places to the right. So 0.125 becomes 125. The other way you can do it is just divide or multiply by 1,000. So to transfer micrograms to milligrams, you divide by 1,000, and to convert milligrams to micrograms, you multiply by 1,000. And the same is true of the milligram to gram conversion. Okay, I did want to talk about liters to milliliters, and I'm going to show you the next slide. You're going to have the exact same math because they are off by exactly 1,000 also. And when we are doing IV fluids, which is everything to do with milliliters here that I'm going to talk about, we're talking in milliliters always. The IV pumps are programmed in milliliters. So you can see the big one here is 1 liter, but it's really 1,000 milliliters. And then you have 750, 500, 250. There's 50, there's 10, there's smaller bags of milliliters. And they're always milliliters, but you will get orders for like, give 2 liters of normal saline. And you in your head just need to convert that to milliliters when you're programming them into the pump. You know that this big bag is 1 liter, but it's 1,000 milliliters. So here's the math to convert. It's the exact same math as you use for micrograms to milligrams or milligrams to grams, but you really don't have to do any of this math at this level because we just think in milliliters for IV fluids. And right, oh, this is what I said earlier, that if you're given 2 liters, it would just be 2 of these 1,000 milliliter bags. Okay, converting, this is one that you're gonna have to memorize as well, is converting pounds to kilograms, because a lot of the conversions that we do with medication math is in kilograms, but a lot of times you'll know the patient's weight in pounds, so you have to convert. So all you do is just divide by 2.2. Remember that you weigh less in kilograms, so divided by 2.2. So 22 pounds divided by 2.2, you'd be 10 kilograms. 80 pounds, you'd be 36.4 kilograms. And when we are doing math, and this is really important, for this class, when we are doing math, and the first step, if there's a weight-based problem, is we're going to convert to kilograms, always round it to the nearest tenth. So 36.4 is where we would round that to. Oh, and this is what I just said right here. All right. So you do your weight base first. And so if I did 300 pounds divided by 2.2, that equals 1.36, repeating. And this 36 goes on forever. So we are going to round this to the nearest tenth. And that would be, this is a 10th place. This is a 6. It's a 5 or higher. So the 3 gets larger. And it is a 4. So 136.4 would be the correct answer for this. For exam questions for rounding, just always follow the directions. We're going to tell you round. If we don't say round, then don't round. But if it says round to the nearest whole number, that would be here. Round to the nearest tenth would be 1,256.5. And because this 9 is a 5, and round to the nearest hundredth would be 49, because this is a 3, so the 9 stays as a 9. That is rounding. Now, calculations with multiple steps, you're not going to round between the steps. You're going to just do all of the calculations on your calculator in one swoop and then round the final result. So like if I have this problem right here, say I'm doing a desire over half times quantity, I desire 147.9. I have 13.37 and 16.5 milliliters of something. So when I do the math, 147.9, and this symbol here means divide. If you didn't know that when we do it on the keyboards here, this is a division. So 147.9 divided by 13.37 times 16.5 equals this really long number when you do it all out at once. So I'm going to show you what happens if you round. So this is the answer that you'll get if you just do it out, if you just put it in the calculator like this. Because these two numbers divided equals this, and multiplied by this gives you this number. But if you did this first step first, if you divided, and then you're like, oh, that's a really long number, I'm going to round it, and I round it to 11.06, seems safe, but you're getting a slightly different number here. And then if you rounded it to 11, you'd get an even different number. So if in the directions for an answer, we said round to the nearest tenth, and you did this a different way, the correct answer to the nearest tenth would be 182.5. But if you had rounded to 11 here, you'd have 181.5. And if we said round to the nearest whole number, this would be 183. This would be 182. And this would be 182. So it's really important not to do any rounding until your answer. That's the only thing you round, except for your weight. You are going to always do your weight into kilograms first and round that to the nearest tenth for this class. Okay. All right, so this is drip factors. This is just a formula that you have to memorize. It's the total volume that you're going to be infusing in milliliters. Remember, IVs are milliliters. You're going to multiply that by the drop factor, and you'll be given both of these numbers, and you're going to divide that by the total time of infusion in minutes, and that's going to give you the drips per minute. So you have an order here, ampicillin 500 milligrams and 300 milliliters of normal saline IV over 40 minutes. So how much volume is being infused? We're going to put in 300 milliliters. And the drop factor, tube and drop factor is 20. So we're going to multiply that by that. And the total time of infusion in minutes is 40 minutes. So this is exactly how we set it up. And we get 6,000 drops or drips over 40 minutes, gives us 150 drips per minute. Okay, let's do another one, just practice. So pause the video, see if you can do this one yourself, and then we'll go through it. Okay, infuse 1.5 liters over normal saline over 12 hours. Now, this 1.5 liters and 12 hours are different because we're looking for milliliters and we're looking for minutes. So there's a couple conversions we have to do before we can do the problem. So let's go through it. 1.5 liters is 1,500 milliliters. And we want 12 hours. Now we know that there's 60 minutes in every 1 hour. So I'm going to multiply 60 minutes by 12 hours to get the total time in minutes. And that's going to give me 720 minutes. So when you're looking at your math problems, just make sure that you are in milliliters and minutes to do this conversion, to do this calculation. And then when you do it out, this is the answer. You come up to 31. And here I said round to a whole number. So the answer is 31 drops per minute. Okay, so desire over half times quantity equals amount or equals dose. This is really a base formula for figuring out how much medicine you're going to give to your patient, or how much fluid, how many pills, based on what you have available to you. So if you have an order for levothyroxine 150 micrograms by mouth daily, the pharmacy dispenses 75 micrograms. How many pills do you administer? Well, you can probably do this one in your head, which is fine, but it's important that you understand the formula. So you desire 150, you're going to, and what you have is 75 for each one pill. So you're going to divide 150 by 75, and you're going to give 2 pills. That is the basic formula. Okay, so let's do some practice questions. And I'm going to ask you to pause the video and do these on your own, make sure you understand, and then I will give you the answers. So it's 7 million Tylenol, I'll say Tylenol, 160 milligrams times 1 dose. We have 80 milligrams per milliliter. How many milliliters will you administer? So we're going to divide that, and we're going to get 2 milliliters. All right, and I'm just going to give you a few more practice questions. Ibuprofen, we have 15 milligrams per kilogram times 1 dose for a child who weighs 22 pounds. The pharmacy dispenses ibuprofen 160 milligrams and 5 milliliters. How many milliliters will you administer? And then round to the nearest 10th. So first we know that we have a weight. So the very first thing we have to do is convert. You have to know, right? You have to know the desire before you can start calculating. We don't have any idea how much the total dose we're going to give is, because it's 15 milligrams per kilogram. And we have to know the kilograms and then multiply that by 15 milligrams to get the actual dose. So first we're going to get the correct weight. And then we're going to multiply, it's 10 kilograms. We're going to multiply that by 50. So what we desire is 150 milligrams. Now we can use the desire over half times quantity. I have desire 150. What I have is 160 over 5 milliliters. And when you do the math out, then you get this long number, and it says round to the nearest 10th. And this is a 10th spot here. This is an 8, so this is going to change into a 7, and this is the answer. Okay, so remember, I've already mentioned this, that IV pumps are programmed in milliliters per hour, so you need to know the hourly rate, which is how many milliliters to infuse in each hour. And it might be written out. It might say infuse 1 liter of normal saline IV at 150 milliliters an hour. So there you have the rate. You're just going to program that into your IV pump, 150 milliliters an hour. But you might have to calculate it. So if it says infuse 1 liter of normal saline IV over 8 hours, I don't have the rate, but I know how much I have to infuse. 1,000 milliliters, and over how long? 8 hours. So the formula for that is the volume divided by the time equals the rate. So if I do 1,000 divided by 8, I get the rate is 125 milliliters per hour, and that's what I would program my IV pump. Now, these three factors are all related to each other. The rate times time equals volume. So if you just remember that one piece, rate times time equals volume when it comes to IV, then you know that volume divided by time equals rate, and volume divided by rate equals time. It's kind of like, you probably remember from math class doing like these multiplications, like 2 times 3 equals 6. So if I know that, then I know that 6 divided by 2 is 3, and I know that 6 divided by 3 is 2. So the same concept, the same relationship is true with numbers as it is with this volume, rate, and time. So if you remember this one, you can invert the others to get the volume or the time or the rate. You'll always have two of those, and you just have to find the other one. And you can pause the video and read over the explanation of how to do these in the practice problems. Okay, so we are going to do a couple practice problems here as well. So infuse 1 liter of 0.9 sodium chloride, this is normal saline, over 2 hours. At what rate would you set the IV pump? So I'm going to do 1,000 milliliters over 2 hours. So I have the volume and I have the time. Remember, IV pumps are programmed in milliliters per hour. All right. And the answer is 500 milliliters per hour. Infuse 1 liter of normal saline over 30 minutes. At what rate would you set the IV pump? So this is it would be volume divided by time equals rate. You have the volume, we have the time, but we have the time in minutes. And we need the time in hours because IV pumps are set up in milliliters per hour. So you have to convert the minutes to hours. And you do that by dividing. 30 minutes divided by 60 minutes equals 0.5 hours. It's a half an hour. You can see that. So you might not have to do the math on that part. You might just know that. So then you would say 1,000 milliliters divided by a half an hour equals 2,000 milliliters an hour. And this last problem is infuse 250 milliliters of half normal saline, and this 0.45 is exactly half of 0.9. So that's what half normal saline looks like. And we're going to do this over 15 minutes. At what rate would you set the IV pump? So we have the volume and we have it in milliliters, so we're good there. But we need to convert the minutes to hours. So same principle, we're going to divide the minutes by 16 minutes to get the hours. And you know that 15 minutes is a quarter of an hour, and that's exactly right. It's 0.25. And then you come up with 1,000 milliliters an hour. And these are my references. All right, well, we went by that quickly. If you have any questions, please definitely reach out to me or reach out to another professor, and I wish you the best of luck on your quiz coming up. All right, there we go. Bye-bye.